So on this temperature-specific entropy diagram, this red line here, this red curve, is our saturation curve. And on this side, it's a saturated liquid. And on this side of the critical point, it is a saturated vapor. So as it's going through its phase change, this horizontal line between points 2 and 3 is the latent heat, and it's latent heat of vaporization. It's the heat that's added that's not raising the temperature, right? It's a constant temperature process that's not raising the temperature of the fluid. It's just converting the water molecules into steam molecules. So it's like breaking their bonds so they're further apart, and it becomes a different substance, just like melted butter is still butter, but it's a liquid version of the solid. So as we get all the way up here to point 3, we learned that that is 100% quality. What that meant was any heat addition after this point, after the red saturation line, after the one it's achieved 100% quality, is back to sensible heat, and it raises its temperature. So if I gave you a point on a Mollier diagram of a given pressure and a given enthalpy, and it fell above that saturation line, there would also be a temperature line, and you could see how far above saturation temperature that steam was, how far superheated it was. So the idea is you could do the same with how subcooled it is, which means how much more sensible heat has to be added. How much further do I have to raise the temperature in order to get it to its saturated liquid point? And in our steam tables, what we need to do is find the saturation temperature for point 2. And the pressure that I gave you was 27 point something inches of mercury vacuum. So what we have to do is we have to convert that to a pressure. And I've shown you how to do the pressure conversions, and that 27.1 inches of mercury vacuum is from a relative zero of atmospheric pressure. So let's flip that around so that we're talking about an absolute pressure. So we subtract 27.1 from 29.92, and then we convert that to PSIA. Once we have an absolute inches mercury pressure, then we convert it to PSIA, and what we should end up with is about 1.4 PSIA. So the problem I gave you says that this point right here, point 2, for 1.4 PSIA, its saturation temperature is 113 degrees Fahrenheit. And I told you that the liquid is at 108 degrees Fahrenheit. So all you do is you find point 2 based on the info I gave you and subtract the data point I gave you from that. So you subtract 108 degrees Fahrenheit from 113 degrees Fahrenheit, and that tells you that you have to raise the temperature of that fluid 5 more degrees Fahrenheit in order to reach the saturation point, in order to get to the point where its temperature won't go up anymore. At that point, it starts to go through the phase change.